All right. Rate of change. Rate of change, when they say f of x equals x squared plus 2, and they want me to find the rate of change for the intervals. Now, it's very important that it says interval, because that tells me that these next things listed are not x and y's. Because that's an interval, this is a starting x and this is a ending x, not an x and a y. And they want me to find the rate of change from this x to this x. Then a separate question from this x to this x. And then a separate question from this x to this x. So the problem is they gave me all x's and no y's. So what I have to do is use the x's to find the y's, which will get me two ordered pairs. Do you see how if I have two x's, I can plug those in and find two different y's, and then I've got two ordered pairs to find a slope between. No, the key word is interval. No. Interval means if I say listen, I want to talk about the time period between 2010 and 2015. Those are same periods. Like that's a year compared to a year. An interval is going to be like that. So if I said I'm talking about this interval between -2 and 0, I'm talking about between x being -2 and x being 0. I want to talk about the slope between that period of the graph. And the way that you would do that is saying this x and this x. We're talking about this piece. So what I have to do is go, I know the x. How do I find the y? You plug in. -2 squared is going to be a 4. 4 plus 2 is 6. So there's one ordered pair. Then I use the 0. 0 squared is 0 plus 2 is 2. Now I've got two ordered pairs for this interval. I do y minus y, 6 minus 2 over, since I did 6 first, I got to do -2 minus 0, which is 4 over -2, or -2 is my slope. That is the slope for this interval. It's an average rate of change because it doesn't have a slope. This right here is a parabola. A parabola is a U shape. It will change. Like, look, if I go from here to here, that's the slope. But if I go from here to here, that's the slope. If I go to here to here, that's the slope. Go here to here, this is the slope. There's no, when I'm on a line, the slope is rise over run, and it's rise over run, and it's the same no matter, even if I went here to here, it's just like a 1/2, right? I went up 1 over 2. Well, this one would just be up 2 over 4. They're going to be the same slope. This doesn't have that, so we call it an average rate of change, because it's like we forget about going to the other points, and we're just saying on average, how do we get from this point to this point? I don't care that it looped to get there. What was the average over that time period? So you would keep doing this. You'd have to do this for this problem and this. So you'd have 2 more slopes to do. So you would do 0, 2. You don't have to plug that in because you already have that. You can steal it from right there, right? And then I'd plug in 3. 3 squared is 9. 9 plus 2 is 11. So again, 11 minus 2 over 3 minus 0. 9 over 3, or a 3. Notice the slope's not the same. Why? Because it's a parabola. It's not going to stay the same. If I did that linear, I would get the same slope here that I got here. And like I said, one of them might be a 1/2, and the other one might be a 2/4. But again, the 2/4 is going to reduce to a 1/2. Okay, so you'd have to do it again one more time. You don't have to plug in for this one because you've already done the -2. It would be this order pair. You've already plugged in the 3. It would be this order pair. So you'd use those two and find the slope between it. And then what it's supposed to do is say compare them. You'd look at it and go, they're not the same slope because the average rate of change doesn't stay the same on a parabola. That's what they're asking. Number 8. Okay, when I do these, all it's asking, I'm not doing number 8 right now. I'm just talking through all these kinds of things. If I have f of x equals -2 x plus 3 squared minus 2, It's asking me, like, what have we talked about? Everything outside the parentheses, what do we say has to do with what? Vertical something, okay? Everything inside has to do with horizontal, right? So that helps me remember that, hopefully. This is going to be moving it up or down, so we call that a vertical shift. Down 2. That's what number 8 is asking you, the transformation. So you're just going to describe. So if I was doing the what are the transformation, I would say vertical shift down 2, vertical stretch by 2, vertical reflection, because it's flipped. That's what that negative said. And then I would do horizontal to the shift left 3. Oh, yeah. Yeah, that's why I taught it to you. Yeah. When I teach you something, it's important to learn it. Yep. Yep. So then, if you know, I told you everything on the outside moves the way you think, and everything on the inside moves the opposite way you think. I did that on purpose because even when we do these, like if I have 1/2 outside, it's called a vertical because it's outside, and it's a compression. Anything between 0 and 1 is a compression. Doesn't matter if it's a negative, because the negative has its own thing. The negative makes it flip, a vertical reflection. Okay? So between 0 and 1, we call it a compression. Bigger than 1, we call it a stretch. Well, what happens when I go on the inside? The way I do it is I go, this should be a compression, but I'm on the inside. It always does the opposite of what I think. So it's a horizontal stretch. So I remember the outside stuff, and then I just remember the inside does the opposite of what. That makes sense. That's how I remember it. However you remember it, doesn't matter. Just got to remember it. Okay, it's the same thing. Don't worry about this equaling this. Don't get freaked out about that. Notice what's new. And it's a inside, so it's a horizontal, and then negative does a reflection. Horizontal reflection. That's it. That's all it is for C. That's fine. You can ask all of them. And unless someone else wants to chirp up, you can ask any question. Oh, yeah. Yep. I kind of did this. I kind of talked you through this a little bit, but it's okay. I know I didn't hammer this one home, so I'm okay. What does it mean to be on my x-intercept? See, like when you're a little kid, I tell you everything that it means. Like back in the day, I would say, okay, x equals this because of this. Now I'm not. I'm telling you, I'm asking you for the x-intercept. Once I tell you x-intercept, I've actually told you more information. Does anyone remember the information that I told you? Whenever you're on the x-intercept, what can you guarantee to be true? AKA y equals 0. They're not going to tell you this part. Okay. In this equation, what part of that is really y? The f of x, right? So instead of writing f of x, when I'm looking for the x-intercept, I can put a 0 in its place. So 0 equals, whoops, 0 equals x squared minus 64. And then solve it. But be careful because this is something we haven't talked about yet. And we'll talk about it a lot more. It's hopefully taught to you in Algebra 1. We'll talk about it a lot more here in this next chapter. Whenever you put a square root sign in, the answer has to be plus or minus. So the answer is plus or minus 8. So your intercepts are -8, 0, and 8, 0. So that these two things is what you'll be looking for your x-intercepts. Now, on the contrary, hopefully you can pick this up. If I said now I'm looking for my y-intercept, what does that clue you into? X is 0. I'm finding the y. But I know that if I'm on the y-axis, if I'm on this line, I haven't gone right or left any, which means x equals 0. So when they say I want you to find the y-intercept, that means x equals 0. But they're not going to say that to you. They're just going to tell you this part. You have to know that that's implied. And then what does that mean? That means you're finding f at 0, right? Because that means my x is 0. And that means you're going to put a 0 in for x. Remember, always use parentheses. 0 squared is 0. 0 minus 64 is negative 64. So 0, negative 64 would be your answer for your y-intercept. Yes, ma'am. Which one? Domain and range. Let me do number 3. When I talk about domain, I'm only referring to this. I need you to hyper focus on the left and right. So like my graph might go like this. Okay? I don't care about this right here. I care about the left and right and how far it goes. So I really care about this point because that's how far it goes left. And I really care about this point because that's how far it goes to the right. So my domain would be whatever those numbers are in between here. So let's say this is negative 10, and let's say this is 10. I would say my domain would be numbers between negative 10 and 10, because the domain only worries about the left and right. Now, if I was talking about up and down, which would be my range, which 2 points would I care about? Let's pretend this one goes up a little bit higher, and this is definitely. What 2 points would I care about? I would care about this one down here, and I'd care about this one up here. Why? Because that's my highest point, and this is my lowest point, so I'd want to say, hey, my range is going to be between numbers that are between here and here. Does that kind of make sense? Do you understand the concept? Okay, so now what I'm going to do is, now like number 3, it asks me to graph it. Well, first off, that's why we've talked about what kind of shape do I know this is going to make because it's an absolute. And so what do I know this transformation is going to do to that? It's going to move it to the right 4. 1, 2, 3, 4. And I know it's going to be a V shape. Now, notice, I didn't make a nice fancy X and Y chart. I didn't do any of that because they didn't ask me to graph it. I'm only using the graph to help me find the domain and range. Now, notice I knew that the V was facing up because there was no negative here. If there was a negative, then I would have flipped this down, and that would have made a difference for one of my domains or my range. Okay, so it is important to know how to graph it to get an idea. This is what this graph would kind of look like. If you need to make a more definitive one, you can make an X and Y chart, but I feel like you're wasting time. The idea is not to have the perfect graph. The idea is to get the picture, an idea of it, so I can go, okay, what is domain concerned with? Which means all I care about is the left and right. Does this thing ever stop? Like, will this graph eventually get over here? Huh? Yeah, it'll be way up here. Maybe even higher than I can write. Like, I'm talking maybe like way up here. But it will eventually get to this section. Will it get to this section over here? Yeah, eventually, because what does this arrow keep doing? It keeps going left, never stops going left. Does it ever stop going right? So what is my domain? So you could write it as all reals. Now, if it is a fill in the blank test, I don't care if you write that symbol. However, what if it's a multiple choice test? Do I need to know that this is called interval notation and that also means all reals? Yep. Do I need to know that this is the set builder notation? Because again, Mr. Martin, and I know you asked me about your notes. Listen, I'm not here trying to punish you, okay? I'm a coach, and I'm going, hey, you've got a game that's coming up. If you're planning on going to college, you're taking the SATs and ACTs. They don't allow notes, right? And they're multiple choice. Here's the problem. Kids always say, oh, multiple choice is easier. Nuh-uh. Because on the SAT, they could give you this answer choice, they could give you this answer choice, or they could give you this answer choice. You need to know all three of them, because if one of them is there, there's a correct answer. So you need to know set builder and interval notation, because you never know which way they're going to give it to you on the SATs. So if you're like, I know how to do interval, that's great. They give it to you in set builder, you're in trouble. I'm not preparing you just to take my class. I'm preparing you so wherever you want to go after me, you're going to be successful. That's the way that I teach, if that makes sense. So my domain, does everyone understand why it's all reals? Now my range, does this thing ever stop going down? Yeah, where's it stop going down? Where's the lowest point it reaches? Well, the lowest point is right here, but if I go over on this line right here, does everybody see it's the origin? Which is where y is what? And it's only those numbers or above, right? So if I was doing interval notation, remember interval starts at the lowest it can be. What's the lowest it can be? 0 for the y. Is it included 0? Can it be 0, or is it an open circle? It can be 0, so what am I going to use? A bracket. And then it goes to positive infinity because it never stops going up, and I use a parenthesis because I can't include infinity, it's not a number. The way I would do this with set builder notation would be funky brackets, y is greater than or equal to 0. Depends on, since I'm talking about range, I have to do y. Because range only discusses y. Did that make sense? So if we were doing b for that one, it's x squared minus 4. What is this going to do to that? So 1, 2, 3, 4, and then I'm going to have a U shape. Again, I'm not drawing a perfect, I'm just giving an idea to myself. And then I look and I go, does it ever stop going left? Does it ever stop going right? So it is all reals. I don't care whichever way the test has it, interval or set builder, I need to know both. And then range, does this thing ever stop going down? Is there a lowest point? Yes, the lowest point is right here, which is -4, and it's included. And it goes to positive infinity. Yes? And then what if they had this? How would that change my graph? It would be facing down. So then I would have drawn it like that. Yes? My domain would still be all reals, but now my range would say, wait, I don't have a lowest number it can reach, I have a highest. So this thing comes from negative infinity is the lowest it can reach and goes to -4 included. Did that help? Domain and range? Nick?
This number 1, it's not hard, but I didn't know which one. If it's a -8 or -8 lines.
Left. Where does left go? I'm not asking that right now. Inside or outside?
Inside.
Why? That's a problem. Outside the parentheses, or absolute values, or any grouping symbols, outside is always vertical movement. Vertical, aka up and down. So when they say shift it left, that's not a vertical. So I know it's not outside the parentheses. I know it has to be inside the parentheses. And since it says shift it left 8 units, normally I would think that would be a -8, but on the inside it's always the opposite. So it's a positive. So it would look as fx plus 8. That would move it left 8 units. Inside the parentheses does the opposite and moves it horizontal. Yes? Nothing. It's just like sometimes eventually I'm going to put a graph here and I'm going to put a graph like that. So f of x is the parent. F of x is just, it's like naming it. It's going, hey, this is f of x. And now, aka, this is just a y, but it tells you it's a function, right? And this one belongs to this guy. Whereas when I do g of x equals, and it's over here, this is the g of x function. Because if I just drew graphs on a paper and I was like, hey, here's one, hey, I want you to look at the graph. Which one? The graph. So I call this one f of x and I call this one g of x. It's just so you know, hey, look at g of x. Now you know which one we're talking about.
So it's really just asking how to get g of x.
Nope. So f of x is the function, the parent. What did we do to the parent to get to g of x? Because it's just the OG. It's just here. All it's asking you is basically what was the transformations? It's the same questions that you in number 9 or 8. Number 8. What does this do? And what does this do? That's it. Left 5 and down 9. Should be A. What number was that? Yep, A's the answer. Yeah. Nope. We're ready to roll. Take the test.
How long we got for the test?
Shouldn't take you long. No.
So we doing something different on Thursday?
Excuse me,
Yes.
could we go over number 6?
Yes, of course. It shouldn't take you more than a class period. The 45 minutes. So
what about the other classes?
that's all they're going to get. It shouldn't take them more than that.
I think we can start different classes.
Mm-hmm. We'll keep rolling. We're already like 5 sections behind. Because I'm going very slow. I'm going real slow, trying to get you, because I feel like if I get you up to speed, I can kind of kick it into gear later on, and I'd rather not leave you completely in the dust. I know I'll leave you a little bit, but I feel like I can drag you along a little bit and keep it going. But I gotta kind of move it. But we're way behind. Right to chapter 2. No, we'll kind of we'll pick it up a little bit. Some of the stuff that we've talked about now is going to help us, and it took a long time. Will help us in that. All right, number 6, did you say?
Yeah.
Number 6. So when we do this, I'm not going to do number 6 right now. I'm going to talk about these two together because they go together, and I don't want us to mess them up. So positive and negative, and then increasing and decreasing. So if I have my graph, where is my, let's say this is my graph, okay? I'm going to highlight my positive sections. My positive sections would be here and here. What is important key point for me to find my positive and actually my negative sections? The X, not the Y, just the X-intercepts. Why? Because what is this line right here? This whole line is where Y equals 0. What happens when I'm above it? My output is positive. What happens when I'm below it? My output is negative. And that's what they're referring to. When they say, I want to know where it's positive, they're saying, hey, I want my output to be positive. You tell me the input that gets me a positive output. Hey, you know what? I want a negative output. What X is what I use to get a negative output? And you say, hey, you use any number less than this, you're going to get a negative. You use any number between here and here, and you're going to get a negative for your output. You use a number between here and here, you're going to get a positive output, Mr. Martin. You use a number after this, you're guaranteed to get a positive output. Because I can look at the graph and see those. Now, increasing and decreasing is different, right? What points are important for increasing and decreasing are my maximums and minimums. Because from here to here, what is this graph doing? Always left to right. It's increasing. What is it doing from here to here? Decreasing. And what is it doing from here to here? And so those would describe my increasing and my decreasing. So what do I care about for positive and negative? X-intercepts. What do I care about for increasing, decreasings? Maximum and minimums, because that's where the change happens, right? At this maximum, I was increasing. Once that max happens, now I'm decreasing, right? What happens at the X-intercept? I was negative outputs. Now all of a sudden I'm becoming positive outputs. You guys get what I'm talking about here? So for your number 6, it's talking about increasing and decreasing. So all I care about is the maximum or the minimum. Well, since I know this is a parabola, I know the vertex is where the max or the min is going to happen. Since this thing is positive, I know it's going to be an up-facing parabola, meaning it's going to have a minimum. Whoever asked me, am I making sense to you?
Yes.
You can stay unmuted for me.
Okay.
So then I'm going to graph this sucker. This only tells me to go to the left 3. So 1, 2, 3. And again, I'm not using this graph. I'm not making this full graph. I'm just giving an idea of what this graph looks like to help me out. They didn't ask me to graph it. If they asked me to graph it, I'd have to get more points. But since I'm just using this to help me with my increasing and decreasing, really all I care about is this point right here. Does that make sense?
Yes.
So what is the graph doing? This part right here, what is it doing?
Increasing.
Left to right.
Left.
No, I mean going from left to the right. You see my pen?
Yes.
If this was your bank account, is that good or bad?
Bad.
That's because it's what?
Decreasing.
Yes. If this is your bank account and this is what your bank account was doing, what would you call that?
Increasing.
And we're going from left to right. Notice I never took my pen from the vertex and went like that and asked you what it was doing. I went from the left and went to the right to show you. Do you get what I mean by that?
Yes.
So I'm talking about my X only because my intercepts or my inputs. This is my X. What number am I coming from on the left side, and what number am I stopping at for where this decrease happens? Well, there's no stopping, right? It's got an arrow, meaning it comes from negative infinity. And that decrease is going to happen. It's going to keep decreasing all the way from negative infinity, all the way until I get to -3. That is where my decrease is happening. Did that make sense?
So the increase is the X and the decrease is the Y.
Nope.
So that was just for decreasing.
The decrease is what's happening to the Y.
Okay. Because
From
it asks like
right,
for,
the Y keeps going down. Do you see how my Y is going down? My Y is going down. That's why I'm getting closer and closer to the X-axis.
Yeah.
You have to tell me what the X's are where that decrease happens. So this is actually an X, and this is actually an X as well. It's from negative infinity X to the -3 that the decrease is going to keep happening. And then from -3 on my X to positive infinity on my X. So going this way, from this point right here, going this way, my graph is going to keep going up. So it's going to be called an increase.
Okay, thank you.
More questions? I'm going to do the piecewise function, number 9. If I was doing this with my mouse, I'd be a master. It's crazy hard to write with your mouse. All right, so here's what we're going to do. We're going to do the piecewise function. Because this is a constant, I know no matter what I put in for X here, it's not going to change. What's my output always going to stay for this section? Careful. My output's always going to be in -6. If I put it in -10, what's it going to kick out? If I put in a -9, what's going to kick out? If I put in a -1, what's going to kick out? If I put in a 2, what's going to kick out? If I put a 3, no longer a -6. Why? Because a 3 is not part of that interval. I would be going down here and I'd be in a different part of my graph. So this it only kicks out -6 between X being -10 and X being 2. So go down here. Between -10 and 2, it's going to always kick out a -6 for this part. And it was not including the first one. It was including the second one. The way I know that is it's not equal to, and the other one was equal to. And I just draw a solid line going across that. That is the graph of this first piece. When my X is 3, that no longer satisfies piece 1. I go here. So now I'm going to graph piece 2. I recognize that it's a line. Since it's a line, the only thing I care about is my beginning and my end. Where does this thing start at? For what X is it going to start at? 2. And what X is it going to stop at? Nick, are you with me?
Yeah.
So this is my starting point X, and this is my ending point X. Now, what's the problem? I don't know where the Y is, right? How do I figure that out? I plug it in, right? So 2 goes into here to this X. 2 times 2 is 4. And then I do the same thing with the 8. Plug it in there. 8 times 2 is 16. And both of them are not including. They're both just less than signs. They're open circled. So 2, 4. And notice I'm not doing a great job with my graph. 2, 4, open circle. And then what was the other one? 8, 16. So we're going to call this 8. We'll call this 16. I know it's not to scale. And it would be like right here. And I would just connect those 2 dots. Yes or no? Then finally, what do I recognize? My last piece is still also. It's still a line. I know that because it's just X to the first power. If it was X squared, what would it be? And I would not only need my beginning and my ending point, I would also need my what? My vertex. By the way, this is being recorded right now, so if you're like it's going too fast or something, It's on YouTube. It's Martin's Math with apostrophe. Remember how we talked about the movement left and right, up and down? That's where the vertex is going to be.
So what is 0, -8? That would be the vertex. You know, look, you don't do the thing.
It would be like if I had this. The first point I would put my X and Y chart would be right 3, up 2. That would be the vertex. That's what that movement does. That's why I taught you that. And then I would plug in the beginning point and the ending point to see where it starts and ends. But this one's a line, so I don't need to do that. This one's a line, so all I need to do is really plug in 8 and also plug in 16 and see what happens. Because it's a line, I only need 2 points. I plug in 8 minus, or -8 plus 2 is -6. -16 plus 2 is -14. So I get 8. That's a closed circle. This is an open circle, so 8, -6. Open circle, 16. -14. This was a closed circle. I lied. This is an open circle. No. Nope, you guys are doing a paper pencil. They're going to do it through Performance Matters. When they get to the SATs, they will not be able to do that anymore. It will come back. So if anyone online decides to try to do that, it will come back to get them. I promise. I have kids who are at SPC who did not take their time and do what they're supposed to in high school, and they are taking high school classes over again at SPC, except they have to pay for them. If you take this course the way you're supposed to, you will not be one of those students, and it won't come back to bite you in the butt because it costs like 3 or 4, probably about $500 including the book to take a class at SPC, and they have to waste a whole semester. So when it only should take you 4 years to graduate college, it might take them 5, which now they don't get to get out of the workforce in 4 years. So now they lost $50,000 or maybe $100,000, depending on your career. It will come back to bite you. If you go to SPC or you go to any college, you have to give an SAT. You don't get a certain score, they'll put you in remedial classes. If you go to SPC, they give you a college entrance exam. It's called the, what? Yep. And if you don't, the PERT's not a pass or fail. It's a placement. So when you take that, they'll put you in a certain course. And if you don't get like a 123, that's where you need to be. That's the college. So it will come back. It's not, you're not wasting it. I'm not being mean to you guys by doing this. I promise. I know what I'm doing. No.
So if I want to go to university, I will have to take this class.
You will. You'll take a class called College Algebra, and it's almost the same exact. Bye, guys. It's almost the same exact course.